The next bullet point I had was apt technologies. And we can see the sorts of estimates, very crude estimates, I ask you just in this context to accept them, of the kinds of demand reductions that could be brought about by the deployment of apt technologies. And there's no one technology that's always apt. It depends on the context. It depends on the specific circumstances we find ourselves in. The things I've highlighted in red are to do with lifestyle change, get people to stop driving, or get people to live more frugally, or get people to buy less so we produce less. Affect our balance of payments, of course, and that has other economic knock-on effects. And then the ones in white are all the things that we talk about in the built environment. We could put more efficient systems in. We could have a biomass heating system to replace a gas-fired one, or we could put a ground source heat pump in instead of a gas-fired boiler plant. We could go more passive solar. We could embed renewables. There's things we can do. My message, however, is what should we do? If you sell one of these technologies, you're likely to market it and say, oh, it's a fuel cell and it's very, very efficient and it's very adaptable. But the real world isn't as kind as that. When we go into the real world, we often find that the efficiencies or the coefficients of performance don't hold up all the time, or the heat-to-power ratios are so variable that the CHP plant doesn't quite realize its potentials. And therefore, we can't just identify something and say the large-scale deployment of that is a solution. It has to be done in a design context by people who understand the fundamental underlying thermodynamics in this example. So that's my next message. Even if we go for a technological solution, it's complicated. Now let's look at the supply side. And what I'm justifying here is why we have to hold all supply potentials in balance. That's what I'm going to justify to you. So on the supply side, when we come to fossil fuels, we have reserves left of fossil fuels. The little graph there is just to show you that as the consumption of fossil fuels rises, historically, the amount of reserves have risen as well as the oil companies explore more, tap into new fields. And that has historically been far greater than the rise in consumption. Now, we can all argue about the data and whether the oil company data about known reserves is correct or not. But I think it's fair to say that we have reserves of that order. These are global reserves now, so the world would not have to particularly concern itself for a good while if it was using coal. I'm not advocating the use of coal, going back to miners and we all burn coal fires, but there are other products we can get from coal, oil and gas. So what's the outlook? If you look internationally, oil is the single biggest commodity of international exchange, and yet it's less than 2% of GDP. So where's the financial incentive for the world to suddenly run away from oil? Yes, the price can go up, and maybe the GDP will go to 3% and 4% and 5%. It will come to a point where the commodity is so scarce that people will have to turn away. But that hasn't happened yet and will not happen for some while. The UK currently spends 6% of its GDP on fossil fuels. But look at that stat there. That's £75 billion per year. But we also spend £10 billion a year on food that we throw away. And it just shows you the sorts of lifestyle balances that we have. Where we have a marketplace that's 2-for-1 offers, and we grab that, but we can't quite consume it, so we throw it away. So we're throwing away a seventh of what we're spending on energy. So there needs to be quite radical shifts in the way people view these issues before suddenly we all start saying, well, I'm not prepared to pay those prices. So I think it's safe to say that the fossil fuels will dominate the world economy for another 2 or 3 decades. If we find, as is currently happening, more resources. BP are trying to open up the tar sands in Canada, and that's a vast oil reserve. It needs to be economically viable to extract it, And these are the sorts of challenges for the next 30 years, and maybe 40 years and 50 years as we try to prolong the lifetime of the fossil fuels. Refiner exploration techniques like horizontal drilling, which allows us to take a lot more oil out of the well than we previously could. Make it less polluting. Have a decarbonisation market. Americans have been doing that for a long time. Enhanced extraction. Sequestrate the carbon and use that to pump out more oil. So put the carbon back into the extinguished wells. New resources and new uses, like going for transport. So methanol. So using fossil fuels as the feedstock for methanol production and going big time to hit the transport sector and apply that technology in a more efficient way. Nuclear. Little quote from Patrick Moore there. And it's true. It's very, very difficult to have a rational discussion on nuclear because it invokes fear issues. We begin to think, oh dear, that's weapons, that's nuclear powers exploding and legacy of radiation damage in our future generations. And we think in those ways. It's actually much more productive to think of nuclear as the same as a conventional power plant. It creates steam and that drives a turbine. And the actual pollution size, the waste from a nuclear power station, is not unmanageable. It is not unmanageable. So at the moment, fission is about 6% of global energy production. It's more expensive than fossil fuels, and it has historically been less expensive than renewables. Renewables are characteristically quite expensive, and that picture will change slowly over the coming decades. Obviously, radioactive waste is a problem, but there are initiatives to transmute, to lower the mass and the radioactive level of the waste. So there are technological ways that we can get to grips with that. The world has about 100 years of uranium-235. Well, we've got something like 14,000 years of uranium-238, but uranium-238 is the one that gives rise to security problems because it's a source material for plutonium. And therefore, that does present us with a problem. So we've got 100 years of 235, which is fine. And then there's all the proposals. There's good side and bad side to use thorium, which is a lot more abundant than uranium, and it has great resistance to proliferation. You can track it very easily. Yeah? You can't move it around without people knowing you're moving it around. Therefore, there are solutions. And of course, I'm duty-bound to say, if talking about nuclear in the very long term, the next 100 years or 150 years or 200 years, we may have commercial fusion, which doesn't present these problems. And we have an abundant fuel supply on Earth. And maybe that's the future of the Earth, to have a balance between the renewables used wisely, used every day, used distributed in a distributed manner, and in all our baseload provision from a clean nuclear.